Hey everybody, welcome back to Young Engineers. I hope you are ready to continue learning with AutoCAD Fusion 360 because that's what we're going to do today. We're going to go over a little bit of the design process. We're going to spend some time looking at one of the more complex models that Autodesk provides for you so you can see how they're put together, and we're going to spend some time making something a little bit more complex than yesterday's cube. So hopefully that should be a little bit more interesting. But there was a thing I was going to say. It left my head. So I'm going to assume it wasn't that important. Let's get started. So yeah, like I said, we're going to go over design thinking and then Fusion 360. So I'm going to go ahead and assume that a lot of you guys are here because at some point you said, it'd be pretty cool if we made something like this, or, how would I build that, or what if we could do this, or, whatever. Some sort of idea that just pops in your head, and, you think about how to make it. To at least some degree, whether it's a program, or it's a machine, or it's whatever. It could be any number of things. So today, we're going to spend a little bit of time looking at the how. So to be more specific, we're going to be looking at the design process. And that is one of the tools in an engineer's repertoire. In fact, there are a lot of tools in an engineer's repertoire, both literal and figurative. And this is one of the ones that, exists in your head. But regardless, it is a tool, and it's useful. So, for an example, let's think of a mousetrap. It's good old Ralph Waldo Emerson's famous quote, "Build a better mousetrap and the world will beat a path to your door." Words. Anyway, we got three different types of mousetraps here. We've got the original, sort of more iconic mousetrap, the kind that you think of when you think of a mousetrap. You get the kind that you see in cartoons and stuff like that. Sitting over there on the left-hand side. And then you've got one in the middle, kind of looks like a house. It's got a smart mouse on it. I guess, hence smart mouse trap. Look at me, so smart. Then you got one over here that's just looking shady as all get out, with some peanut butter slathered on a tube that's suspended over a paint bucket with some ramps. Yeah. Anyway, the point to illustrate is that the same problem, in this case catching a mouse, can be solved multiple different ways. So what makes one solution better than the other? Like seriously, is there a hey Kai, is there a mousetrap that is better than the other two? Like, is there one that you think is superior to the other ones? Think about it for a second. See if you can't form an opinion. Let's spend a minute or two looking at the pros and cons of each of these. So, the first one, the Victory mousetrap, or Victor, I guess, it's cheap, it's effective, it's easy to set, and it's easy to release. It's easy to trigger. The mouse dies, and the mouse is unable to escape from it once it's triggered. Mostly, usually because they're dead. The second one, the mouse house, costs about $12, so it's not really cheap. It's actually pretty expensive as far as mousetraps are concerned. It takes up a decent amount of space, but it is easy to set, and the mouse lives. The mouse can escape, so it's possible for the mouse to get out of the mousetrap at some point. And then that ramshackle-looking one, well, it can be made from things lying around the house, so that's nice. I mean, you got peanut butter, you got a paint bucket, got some cardboard, you got whatever that thing is in the middle. I guess it's I really can't tell from this picture. Anyway, you probably have it in your house. and it's easy to set. The mouse might live depending on what's in the bucket. I mean, if you put, food and stuff in there, then the mouse will be fine. If you put something else in there, then it probably wouldn't live. You could put stuff in there that could kill it. I don't know. And it's possible for the mouse to escape, because really the only thing keeping it from getting out is the fact that the walls of the bucket are probably high enough that it can't jump out. Probably. Maybe. We're assuming here. So, hopefully by this point you guys might have an idea of what the best one might be. And you probably didn't pick that one. It's a guess. Could be wrong, but you probably didn't pick that one. Maybe because it killed the mouse. That might be your reasoning. However, if you lived in a time when resources were scarce, like there wasn't a lot of food, or, a time when mice and rats carried a disease like the bubonic plague, you might have a different opinion, especially if it's something like the plague, which nearly destroyed Europe. You might have a different opinion about mice at that point. You might say, hey, that one's the best one because it's cheap and it works. And the mouse can't escape and the mouse dies. Like, obviously that's the best solution. So, yeah. I haven't messed with the text on this one because I'm not sure why this exists. So I'm just leaving that there until later. I'm also not sure what it's trying to say. Anyway, that's not what we're paying attention to. We're paying attention to the engineering design process over here on the left. The engineering design process is a circular process. That is to say, there isn't really an end step to it necessarily. Although generally it starts at the top. Sometimes it starts at number 3, but generally it starts at the top. Number 3 working clockwise, I should say. Which is ask. More specifically, identify the need and constraints. So, back to the mousetrap example, let's say you're designing another mousetrap. So you look at it and you go, we need something that can catch mice, not kill them, but not allow them to escape. So far you've got a need, something that catches mice. And you've got some constraints. It can't kill them, and it can't let them escape. So now you got to research the problem. You look into different types of mousetraps to see what works, what doesn't work. What fits with what you're trying to do, and maybe what isn't the right thing, so you can, get both sides of the issue. And then you maybe spend some time researching mice themselves. Maybe how they respond to certain situations, how they operate, what they're looking for. So you can bait a trap more effectively or make it seem more inviting to a mouse. Maybe how much they can do, so you can make sure that the trap is inescapable. And then you would go to imagine, which is, like I said, one of the things that sometimes people just kind of jump to, develop possible solutions. Because, if you're anything like me, it's sometimes you just look at things and you're like, man, it'd be really cool if this happened. And that's imagining in that sense. You're developing possible solutions. So in develop possible solutions, you would be looking at it's like, okay, so what if we made a mousetrap where the door was stronger? It used a stronger spring. Or what if we made a mousetrap where, it's actually very deep, so they would definitely not be able to jump out, but there's a pillow that they can land on. Or what if we designed a mousetrap that involved, I don't know, whatever. Basically, you just brainstorm a ton of solutions in that one, which moves you to plan, in which you pick the most promising solution. You say, hey, this one's really cool. The fact that it uses a painted-on tunnel to, show them, like, to make the mouse think that there's a mouse hole to go into, but maybe they don't fall for that kind of a thing. Maybe it's not the best solution. Maybe not everybody can paint a fake, mouse hole in their house. So that's probably not the most promising one. It's a terrible example, but it's one that, happened in my head, so yeah. So from that point, once you pick the most promising solution, maybe you pick one that has a stronger spring, that involves a stronger spring on the door, so it's harder for mice to get out, you build a prototype. So you build the mousetrap, you build a tester, and you would test and evaluate that prototype, either with, some nuisance mouse that's in your home, or by releasing one in the general vicinity and seeing if it gets trapped by it. At that point, you would improve. Redesign is needed. So maybe the spring isn't strong enough, so you go back and you'd work on that. Or maybe, you need to put air holes in it, so you would go back and put air holes in it. Which is wrapped up into asks. So you would identify the needing constraints of the specific things that you need to improve. So yes, we need to make the string stronger. Let's pretend I said the spring stronger instead of the string stronger. But you would need to make the spring stronger. So you would go, okay, so that's our need. The constraints are we can only use metals that exist. It can't be too expensive, and it needs to be able to fit in this area. And so there are your constraints. And you would go around again. So that's part of the reason why it's a circle. You would just keep, refining and researching and redesigning and, just improving upon the design. Which, lends I feel like this slide's a little out of place, but the information age. So in school, you'll be limited to what you have on hand. So, you go in to take a test, and the teacher says, okay, you can only use what's in your head. Okay, fine. You can only take the test with what knowledge you have on hand. Sometimes teachers say you can take the test, but with one sheet of notes. Cool. So you go in there and you have a sheet of notes that you can work with. Sometimes they give you multiple sheets of notes. Sometimes it goes as far as being an open book, open note test, so you can take in all of the notes you've taken throughout the semester, you can take in the textbook, and you can take the test. And sometimes, in very rare cases, you can do all of that and you have the internet. Now, generally those tests are really, really hard, and so the notes don't really help you as much as you think they're going to. But, regardless, it's always limited to what you have on hand, which is sometimes more than other times. In the real world, however, you are limited to what the world has on hand. So that's a much larger circle of things that you have on hand. Pretty much everything. So, not really everything. I mean, you can't use a star. But regardless, you have a whole world of resources at your hands. The drawback is you have the entire world to use. So with so many options, it can be difficult to pick one sometimes. Do I want it to be made out of sweet future metal, or do I want it to be made out of wood, or do I want it to be made out of plastic? Maybe I can make it out of granite. That might be interesting. Obviously there are some solutions there which are better than others, but regardless, the idea still stands. There might be decisions which aren't as easy to make. You have a bunch of different solutions on hand, and you aren't sure which one is the best one to pick. It happens. So that's where, selecting a promising solution and refining the process comes in. So now with that in mind, after we've spent some time talking about the design process, we'll spend a little bit more time exploring Fusion. So go ahead and get that open. Mine, I apologize in advance, is going to be very slow, and it's going to take a while to boot up because it's just I got enough things running right now that it's going to spend some time thinking. In the meantime, hopefully, you guys will take just as long so you're not sitting there being bored waiting for me. But I realize that that's probably not realistic. At least you have this nice picture of a desktop background to look at. The clouds going over the mountain, and this, and the power lines, and the valley. I mean, it's all very nice looking. It's all very, very pretty. And of course, Autodesk Fusion is the front of the storm right here as it goes over the mountains. Okay, it's starting up. Slowly but surely. Eventually, though, I say eventually, you should be looking. There we go. Yeah. Oh, Fusion 360 has now been updated. Cool. We'll be looking at the same screen we were looking at yesterday when we started up, with a nice little area that we can rotate around and move back to all that stuff. And our tree over here, and the toolbox and all that stuff. So what we're going to do is we're going to click on the Show Data Panel button in the upper left-hand side. It should be a little grid of 9 squares, and when you mouse over it, it says Show Data Panel. So click on that. And you should see something that looks like what I've got on my screen, with your name and new project and my recent data and demo, blah, 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 blah. So my recent data should be all the stuff like your cube. It should be your cube. Maybe any other projects you've been working on and saved. That should all be listed right there. You also have the ability to upload it to the cloud and refresh it so you can see what's on the cloud, and the grid view so that you can look at it more closely, and all that stuff. Let's go back. I don't have anything there because I never saved my cubes after the classes. So mine is completely empty. You've also got some design samples and some CAM samples and Fusion 101 training, and apparently my first project. You should have your first project there. And then a demo project. So we're going to take a closer look at the demo project. And the way we're going to do that is actually up at the top of the data panel. There's a thing that's a triangle made with 3 dots. So if you mouse over it, it says Projects Punch Out. You're going to click on that, and it's going to open up a new tab in Chrome. And you're probably going to get some tutorial screens and stuff like that when you first open this up. You might have to click on a thing that says Get Started down here, and then it'll point out a bunch of stuff like, oh, you can add things to your project by clicking this right here, and you can go here and create a new project here. And, it's trying to be helpful, but at the same time, it's kind of like, I get it. But you should be able to click out of that stuff. And mine should be loading. Hello? There we go. Sometimes it's a little, there we go. Yeah, and you can just click OK, got it down here at the bottom, and all that stuff will go away. So you can see all the projects that you have, all the deactivated ones, like the ones you're no longer working on. Pinned ones are kind of like your favorites. You can see who else is invited to this project. You can add more people to it. You can see all the people who are working on it, all the projects, all of the different components and everything like that. You can keep track of when progress is made and when it needs to be done by and things like that. So we're going to click on Demo Project, though. Just, it's a quick overview of that stuff. We don't care. We're going to click on Demo Project and click on the picture next to it. It should bring up a new page. And here we've got a bunch of models. All these .im models and SLD, ASM, and stuff like that, and DWF and RVT and blah. All these different kinds of suffixes and everything. We're going to click on the robot one, so robot.im. You can click on it up here, or you can click on it down here. And then it should open up a little thing over here, which you can use to look at the robot. And it's interactive. So once it loads, eventually, slowly, once it loads, there we are, kind of. Still loading. Yeah, here we go. Here's a robot. You can spin it around in 3D. You can zoom in and out. Apparently it's not really quite used to rendering all this stuff from different angles, so some of it disappears. There's one thing in particular I want to show you. So you've got 3 sets of icons down here. You got one set of 5, one set of 3, and one set of 4. we're going to click on the rightmost icon in the set of 3. If you mouse over it, it says Explode Model. And a slider should come up. I'll start dragging that slider to the right. All the parts, ideally, should separate. So what am I trying to illustrate here? Well, I'm glad you asked. I'll tell you. Something as complex as this robot, and don't worry, this is just a simple thing meant to show you what you can do. You can actually do insanely complex things in Fusion 360. I don't know if you're worried about it, but just in case you were, don't. But in order to make something this complex, it's actually made up of smaller parts. These are all the parts that are individually drawn and attached to the robot, like his leg hinges and the little servos there, and then you got like the cover and the upper leg and then the kneecap, and the kneecap's got like a bolt and a nut, and they all go in there, and then there's the lower leg, and the lower leg is attached to the the lower leg bone is attached to the foot bone and all that kind of stuff. And these are all made up of individual parts which all go together. So if we bring them together slowly, you can see exactly how they fit together. So that's really what I wanted to illustrate here. It's that something this complex is actually made up of smaller parts all combined together into one unit or one model. So if we bring it all together, boom, you can see how everything fits together. You can see all the complexities inside the shoulder and how they fit into the arm, and you get the idea. Regardless, so what we're going to do is we're going to see how we can apply some of the techniques that exist in Fusion 360 to make something not this complex, but certainly something more complex than yesterday. And hopefully give you an idea of how something like this torso strut can be made, or this arm can be made. Like you might get a better idea of how something like this could be made, or the actual chest cavity itself. You get the idea. So go ahead and close out of this. Close out of this tab. And oops, sorry about that. I just totally smacked my microphone. And go into Fusion 360. Close out the data panel. And we're going to take a look at some drawing here. So we're going to start out with Sketch. But we're going to start with the Sketch drop-down menu. We're not actually going to draw a line. We're going to draw the base of this gear, which is going to be a circle. So go ahead and click on the Sketch drop-down menu. I mean, you can make it with a line, sort of, if you wanted to, but with great difficulty. So let's start out with the circle. This is going to be a center diameter circle, and you notice it has the shortcut C, which is a few of the drawing tools and stuff in Fusion have their own keyboard shortcut. Good Lord, but not all of them do. But this one certainly does, at least. So you could also hit the C key. So now it's going to ask us which plane we want to draw on. You remember this from doing the cube? I'm sure you do. We're going to start by drawing on the top plane. And if you remember, that's the bottom one, confusingly. But the easiest way to remember is that this plane is parallel to the top plane on the cube, and that's the best way to remember it. I guess, because it's also parallel to the bottom plane. But anyway, click on that one. And your view should change. So you're looking at just these two axes right here. Start at the origin and click, and make it really any size you'd like, because we're going to modify it in a minute so that it's the proper size. I'm making mine 80 millimeters. You can make it whatever size you'd like. and then hit escape once you're done. And you should have a nice, beautiful circle right in the middle of your two axes. Once you've done that, we're going to change the units over to inches. Does anybody remember how to do that? Any ideas? Yeah, exactly, Kai. Exactly. We're going to go over to your units on the left-hand side, and there's this Change Active Units button which appears. Yeah, precisely. With the pencil and the paper and the ruler. Exactly. And then that's labeled Change Active Units. So we got the unit type here. Click on that. Change it to inches. And then hit OK. So now we've got a circle of some diameter. We're not really sure because it's kind of hard to tell now, but it looks like it's about like a little bit over 3 inches. So now we're going to go back to Sketch. I'm going to go down to Sketch Dimension. Boom. Now we're going to click on the circle. Now the tricky thing is you actually have to click on the outside of the circle, the line itself, the blue line, and make sure that it turns like a light gray when you click on, or before you click on it. And then just bring the measurement out to the left-hand side a little bit. As you can see, mine is 3.15, so yeah, a little bit over 3. Click, and then it should highlight. So whatever size your circle is, we're going to change it to 4 inches. So make sure it is 4 inches in diameter. So once you sketch the dimension and the text box comes up, just type in 4 and hit enter, and your circle will resize. It might resize to like a massive compared to your scale. That's okay. Probably you just zoomed way in. So now we have a circle sitting nicely in the center here that is 4 inches in diameter. Nothing we haven't seen before, right? We just did a square instead of a circle last time. So far, we haven't done anything that 1980s AutoCAD could not do. But hold on. We're about to change things up a little bit. So there's this thing, right? It exists. Pretty sure I could have made that more vague. Anyway, it's called the construction line. What the construction line is, and construction lines are, is there things which are a part of your drawing, which help you to sort of like get a scale of things or keep track of certain aspects of your drawing that you can add anywhere, that are a part of your drawing but are not a part of the physical object. So the analog that I thought of last time was like, let's say you're making this circle out of balsa wood, and you wanted to cut some holes in it, right? And you draw on it with a pencil to show like where you're going to cut the lines with an X-Acto knife. The construction line in this case is kind of like the pencil drawing that you have on there. It exists on the thing, but it could just as easily not. It's not an important, like it's not a part of the circle. It's not a part of the finished product. The finished product in this case would be the holes that you cut out of it. This is kind of like a drafting line. So we're going to go ahead and sketch a line directly through the middle of the circle from top to bottom. Start a little bit above the circle, like right here at 2.5, and then go a little bit below the circle. So right now mine is about 5 inches long. So you should have a blue line bisecting, fancy way of saying cutting in half, your circle. If you mouse over the beige parts, you'll notice that they have been divided into individual semicircles. That is to say, the line definitely split them in two. So we're going to go ahead and fix that. Double click on the line that you just drew. You should get a sketch palette over here on the right hand side. And they got a whole bunch of stuff like look at and sketch grid and snap and slice and show profile and 3D sketch, blah blah blah, and just all kinds of things. Midpoint, fix, unfix. We're going to click on the top option, which is normal/construction. So normal/construction. If you click on it, the little icon next to it, it should disappear. And then the line itself will turn into an orange dotted line, which is probably really hard to see on my screen because it's not a great color to show up. But, you know, you guys should be able to see it more easily on your screen. Next, we're going to make sure that this line does not move anywhere, no matter what we do. We got to make sure it doesn't move anywhere. So we're going to right-click on it. We're going to right-click on it and not miss. Okay, it's not showing up. If you still have the sketch palette up here, you can click on the Fix/Unfix button, which is the little lock. Click on that. And you should be able to click on the line and fix it into place. Why is this not fixing it into place? Good Lord. There we go. Click on the line so it's blue first. I don't understand why it wasn't cooperating with me. Fix it. Apparently you can't make a construction and fix it. Oh no, it is construction and it's fixed. Okay, I don't know why that was confusing me so bad. Apparently I'm just bad at things. So anyway, you should now have a green dotted line going through the middle, and if you mouse over the circle, it should be a complete circle yet again. So what we've done is we have created a construction line straight through the middle of the circle, a little bit larger than the circle's diameter, and it is fixed in place, which means it will not move. So now we're going to zoom way in on the top here. Because we're going to add something that's sorely missing from this circle. Because so far we're creating a gear, right? At least I think I said we were creating a gear. If I didn't, surprise, we're creating a gear. Gears have, teeth. The last time I checked, they have all these like bumpy things around the outside of it that make it so that when they turn, it makes another circle with bumpy things on it turn as well. Gears. That's the engineering explanation. Anyway, gears are a device used to transfer mechanical energy, also known as torque. Well, sorry, it's not also known as torque. It's a specific kind of mechanical energy known as torque, from one location to another. Torque is like spinning energy. Power. The math behind gears can be a little complex, so here we're just going to draw one to demonstrate some features in Fusion 3D, features in Fusion 360. So yeah, these gears aren't necessarily going to be like mathematically correct, but they'll sure look like gears, so that'll be cool. The whole idea of doing this is these features that we're going to use are generally universal in most 3D modeling software. So once you learn it here, you should be able to realize that there are similar functions and features in other bits of modeling software, like SolidWorks or Blender or other ones that I can't think of right now that are escaping me. Apparently, it's just not my day. Yeah, we already did the construction lines thing. Construction lines is one of those things. We're gonna... There we go, perfect. So the first thing we're going to do is we're going to sketch a couple of lines. So you can click on the line tool up here above sketch, just a quick select line, and start somewhere on the circle. You'll know you're somewhere on the circle when your cursor is pointing to a blue X, a light blue X, as opposed to the crosshair or the crosshair with the square around it. So click on the light blue X, or click on it when it's a light blue X, and then just create a diagonal line upwards toward the center point. Stop at some point and then go directly right until you hit the center point, or the center line, construction line, and make sure you stop exactly at that construction line. So that is to say, this horizontal line ends right here at the construction line, and you can zoom in to verify and make sure that that's done. Hopefully your construction line hasn't moved. If it does, undo what you've done. Check and make sure that your construction line is fixed, and then try drawing it again. I know it's not a terribly helpful thing to say, but that is the way to rectify that issue. So now we should be looking at half of a tooth, which is about as useless as you can get when you're looking at a gear. I mean, look at that. That's shameful. But we're gonna fix this. How, you ask? I'm glad you asked. I'm going to show you. So we're gonna go to Sketch, right? The drop-down menu this time. And we're gonna sketch dimension. So remember, pretty much everything has to be dimensioned in Autodesk Fusion. So we're going to do this not only because it needs to happen, but also because this will make it possible for us to give this half of a tooth the exact dimensions we needed them to have. So if you mouse over the intersection between the diagonal line and the circle, a white line, or a white dot, should appear. Click on that. And then click on the construction line. Now you can see one of the things that makes construction lines useful. You can also use it as a measurement point. So click on the construction line. Mouse away, and you should see a dimension pop up. In this case, it's 0.177071 inches. We're going to change that to 1/4 of an inch. So just type in 0.25, hit enter, and suddenly your tooth becomes a lot more squat than it was before. But wait, there's more. We're going to keep dimensioning. So now we're going to start at the white dot where the diagonal line and the horizontal line, the top horizontal line, meet. And then we're going to click on the white dot where the horizontal line and the construction line meet. Drag it away. 0.157. Oh, sure. Sorry about that. Let me just undo this real quick so I can show you again. So, sketch dimension. See where the diagonal line and the circle meet? There's a white dot if I mouse over it. You click on that. And then you click on the construction line. And then if you drag the mouse away, there should be a little measurement which pops up. And then when you click that a third time, find a good spot to put it and click it, you can then change the value, which should be 1/4 of an inch. That help? Cool. Excellent. Alright, so yeah, sorry, the top line, we'll dimension that one out too, and that should be 1/10 of an inch. You'll notice now that the tooth has adjusted so that it becomes much longer. And then we're going to dimension out one last thing. So we're going to click on the white dot again where the circle and the diagonal line meet. And then we're going to again click on the white dot where the diagonal line and the top horizontal line meet. So now we're measuring the height of the tooth, and this is different from the length of the slope here. Remember Pythagorean theorem, you know. So we'll click on that, and we'll draw that out. And this one should also be 1/4 of an inch. I was pretty close, but I wasn't quite there. So there we go. Once you've got those three things dimensioned, your tooth, at least the half of the tooth, is now properly sized. For now. We'll mess with it later, but don't worry about it for now. So you'll notice that when I changed the width here, everything kind of moved this way in order to adjust. And then when I changed the width here, the tooth got longer to adjust. And then when I changed the width here, everything kind of moved in a little bit, but mostly down. Don't ignore me, I'm wrong. The angle changed. The angle changed. Good lord, I know how to math. The angle changed so that this one stayed the same length, this one stayed the same length, and this one stayed, or this one adjusted to the proper length, and this one stayed the same length. So at no point did this angle change right here. And you'll also notice if we zoom in, as far as we, yep, there we go, that's why. Let me see if I can keep the circle on that right there. Oh, fine. That's just getting more confusing. I'll get rid of the drawings. You'll notice if we zoom in here, there is this weird like right angle, and then there's these these little symbols next to the right angle. Those mean constraints, and we'll get more into constraints later if we end up doing lesson 3 of Fusion. But constraints basically mean that this cannot change. This has to be a right angle. So it knows that, and then we've given it other constraints, specifically the length of each of these measurements, and so it has to adjust everything so that it fits those constraints. Much like how it would be if you engineered something, I guess. You know, just a thought. But yeah, so that's the whole idea behind that, and that's why it adjusted in a way that we wanted it to. It doesn't always. It tries to best guess, but it doesn't always get it right. So just keep that in mind. It's not, you know, magical, but it's much better than it presumably was in 1982. So it's got that going for it, which is nice. So now we got our half of our tooth. Let's make the other half. I'll show you an easy way to do it. If you go into the Sketch drop-down menu, there's an option called Mirror. Click that. So now the mirror window comes up. You've got two things. You've got objects and you've got mirror line. Objects, as you might imagine, is the stuff that you want to mirror over to the other side. Mirror line is what you want to reflect it across. I didn't realize it was already 8:45. Okay, so you can select multiple objects. We're going to do that here by holding down Shift. You don't have to hold down Shift, but you know. No, actually, I think you do. Anyway, by holding down Shift and clicking on these two lines, so the diagonal line and the horizontal line, we've selected both of those objects as the objects to be reflected. And then we click on Mirror Line, and we click on our construction line. Look at that, coming in handy again. And it gives you a little preview. You hit OK. Boom. We've got one fully realized tooth. Look at that. This gear has teeth now. Or, I mean, really, it has tooth. But most gears have more than one. So we're going to go ahead and add those other teeth manually. Hooray! You weren't supposed to see that slide yet. But yeah, no, we're just kidding. There's an easier way to do it. It's a much easier way to do it. We don't have to do that manually each time. That would be terrible. So we're going to go back into the Sketch menu. And there's this thing called Circular Pattern. Click on that. Now we got a couple of things. We've got objects. So we're probably going to want to select our tooth as the object, which means we have to select all 4 lines now as the object. And I say 4, and that's because you got the 2 on the side, and then the one on the top gets split into 2 because it technically, you know, is 2 lines. You've got the one half, and then it's reflected across, so you've got the other half. So these are 2 lines up here. So select all 4 of these lines, And then for the center point, we are going to click on the origin. Oops, undo that one. For the center point, we're going to click on the origin. And you should see that it already added a couple of teeth. If you zoom out, you should see that it already added a couple of teeth around the circle. But 3 teeth is still kind of a lame gear. So we're going to increase that number. So you can click the up arrow or you can enter it into the text box. We're going to increase it all the way to 13. And then hit OK. Look at that, it's looking decidedly gear-like now. Like, pretty gearish. Now, it should be said, now we already did that, it should be said that there is something really handy about both mirror and circle pattern, and that is it updates in real time. It's assuming that the object you want to mirror will always have the same parameters as what it's mirroring. That is to say, in direct terms, if we change the dimensions here will change. In addition, circle pattern works the same way. So any dimensions that we change here get changed here, and here, and here, and here, and here, and here, and you get the idea. It happens to all of the teeth on the gear at the same time. So let's put that into action. We're going to change the dimensions on this top thing that we have, the one that we have measured. If you guys don't remember how to do that, that's okay. All you have to do is just double click on one of the measurement numbers and then type in your new one, and it will automatically resize it. Now here's a fun thing. Zoom out and look at your whole gear before you hit enter on it. It might hiccup for a second, but then you can see that the entire gear changes. So now we've got like a much more nubby gear. Cool. Alright, let's change the top one. So this one's going to be 0.15 inches. And it's going to hiccup again because it happens regardless of whether or not you know, are currently looking at it. And then we're going to change the height to double. We're going to change it to 1/2 inch instead of 0.25. Zoom out, hit enter. Look at that. That is looking so gear-like I can't even handle it. So, once again, the width of the bottom is 0.35. The width of the top is 0.15. The height is 1/2 inch, 0.5. And there you go. Almost. I lied again. So close. We're not quite there. There's one more thing we have to do in order to make this like a... Well, 2 more things we have to do in order to make this legitimate gear. Let's go ahead and do those right now. So there's one thing under the sketch menu, because you'll notice that all of these are separate from the gear itself, right? Like, that's kind of weird. And I feel like if we built this, those things would just kind of fall off, maybe, you know? So under the sketch menu, there's an option called trim. T for trim. Click on it. And now mouse over lines. You'll notice that the lines that you mouse over turn red. But just the segments. So if we mouse over, say, the circle segment inside of the tooth and click on it, well, look at that, it goes away. So just go ahead and do that with all, of the circle segments. See, perfect example. If you mess up like that, Control Z to undo. And then we got it back. Excellent. Apparently I just had to hit undo one more time. So trim and trim and trim and trim and trim and trim and trim until these are all gone. And we have a completed looking gear. There's one more thing that we need to do, though. That we need to do. Can anybody think of what it might be? I'll give you a hint. Does that look odd? So we're going to need to push or press pull it. So go ahead and click on that above modify. Select your gear. And we are going to extrude it 1/4 of an inch, so 0.25. And hit OK. And look at that. Look at that gear. That wonderful gear. It is pretty nice looking, if I do say so myself. Let's go ahead and get a top look at it again. Zoom in. Because there's one more thing we can do, if you guys are so inclined. And that thing is, we can draw on the gear. Draw, you know, whatever. Draw some things that we're then going to cut out. So let's go ahead and zoom in. And, you know, really, the whole idea is so we get like a design like one of these here, which is kind of neato. So you can draw basically whatever kind of design you'd like. The only constraint I'm going to give you is that it has to be in this first quadrant here. That is to say, it has to be between these two axes. So up here. That's not, I can't remember if that's the first quadrant because I'm bad at math. Now, just to give you an example, I'm just going to start drawing something over here. Oops. Aha. And we'll do this and kind of bulge it out. And we'll draw from here to here. And we'll give it a little bit of a flare there. Oh, it's looking gorgeous. Best thing I've ever drawn in my life. Not much of an artist. I'm sure you guys have already realized that. Nope. Oh, can't do that. We'll keep it as is. Why mess up a good thing? Maybe a circle here. And a circle here. Okay, so we got our design. It looks kind of like a face with a unibrow. So the reason I had you draw in just this first quadrant over here, as I'm sure you might imagine, is because we're going to be using the circular pattern thingamajig again. So select all of your objects. Select your center point as the origin. And we're going to repeat it 4 times. Or maybe 3 times. What about... Nope, we don't have enough to do 5 times. So 4 times it is. Yeah, sure. So look at that. So far we've got like a pretty neato design. I'm okay with that. I was just going to say real quickly, I am aware that it's almost 9. We're almost done with this lesson. We'll do the poll questions, and then I'll be, I'll let you guys out. But let's see here. So modify. We're going to press pull, and now we're going to shift click to select all of these things. After selecting all of them, a blue arrow will be on the last one. that you selected. And you can just drag it downwards until you're sure that it's gone all the way through the gear. Hit OK, and look at that. That is beautiful. That looks serious. I'm so proud of myself. I'm going to save this one. It looks so sweet. Anyway, I'm done drooling over my own design. I'm an adult. I need to do adult things, like not freak out over the fact that I made a really cool looking gear. It's actually not that cool. I'm just kind of proud of how it came out. Anyway, there is one last thing. I know I said one last thing. I've said one last thing like 1,000 times. We're going to put a hole into this gear. We need to, in order for it to, you know, fit onto a thing, right? Like a rod or something like that, and do its gear-given work. I don't know. So we're going to draw a circle around the origin using that diameter circle, or basically you can hit C, 2-point diameter, I believe it was. There we go. Sketch a dimension on it. Now, we can type this in inches. It should be said that most hobby motors, the rods that come out of them are measured in millimeters. So if we wanted to fit this onto a motor, we would have to, like, you know, do the conversion and figure out how many inches are 6 millimeters and blah blah blah. Or we can make our life so much easier and utilize the smartness of the, you know, the programming here, I guess. If you just type in 6 and then the type of units, in this case millimeters, mm, it will automatically resize itself and then give you the amount in inches. So it's 0.236 inches. That's 6 millimeters. Perfect. Press it in. And ta-da! Congratulations. You've made a gear. And it only took about 30 minutes to learn how to do it. So something this complex has come out of just some very simple operations. So pat yourselves on the back. You made a cool thing. Anyway, it is 9 o'clock. I am going to throw out the poll questions. And then if you have any questions about anything that we've gone over today, or in previous lessons, or in the future, or if you just have general life questions, feel free to ask them. I will answer them to the best of my ability. If not, once the poll questions are done, you're more than welcome to head out. Have a good weekend, and we will see you on Monday.